Okay, so in section 6.1, again, we're talking about factoring by grouping. And again, notice you have four terms. And the way we're going to do this is we're still going to use the idea of grouping the first two, last two. But what I want you to notice is this, and that's going to be important when we talk about the rules or the steps to factoring in a couple more sections. But in this problem, I want you to notice that the direction says factor out the GCF of the polynomial. So if you look at all these four terms, the GCF is x. That's the GCF. So the GCF is x. Now, if you go back to all the examples we've done previously to this, the GCF of all four terms was 1. The GCF of all four terms was 1. In this case, it is not 1, it is x. So what you want to do first is factor out the x from these four terms. So I'm going to get x times 3x to the fourth, because x times x to the fourth is x to the fifth, minus x cubed, because x times x cubed is x to the fourth. Remember, you're using the distributive method. And then plus 6x, because x times x is x squared, and then minus 2. Okay? Now, you see this part right here? This right here. I'm going to rewrite it over here. So just rewrite it. Make sure you do that step. Put that step on the side. If you do everything here, it'll be too much work and you may mess up. So do it here. Now, this piece, or this part, we're going to do by grouping. All right, so again, you factor out the GCF of the polynomial of all four terms. You rewrite it, and then take this, and now you're going to factor this by grouping. So the GCF of this group here is x cubed. So I get x cubed times 3x minus 1. And the GCF of this group is 2. So I get 3x minus 1. So notice that in these two groups here, these two terms, the common factor is 3x minus 1. So factor out of 3x minus 1, and you're going to get 3x minus 1 times x cubed plus 2. Okay, now be careful, that is not the answer. The answer is going to be x, because that's your GCF of all the terms, times this, 3x minus 1 times x cubed plus 2. Okay? All right, so that'll be your answer. Now, let's suppose you forgot to factor out the GCF of the polynomial. All right, let's see what happens if you do that. All right, so in other words, I'm going to rewrite this. Okay, and let's suppose we just forgot about the fact that the GCF of all these four terms is x. So let's group the first two, group the last two. From the first group, the GCF is x to the fourth. So I'm going to get x to the fourth times 3x minus 1. And over here, I'm going to get the GCF here is 2x, and I'm left with 3x minus 1. All right, so just like right here, the common factor is 3x minus 1. Same thing here. Common factor is 3x minus 1. So it looks good so far. And you're left with x to the fourth plus 2x. Okay, now here's the issue. If you look at this factor right here, it is not factored completely, because if you notice, if I cover this part here, x to the fourth plus 2x, there's still a GCF here. What's that GCF? Well, that GCF is x. So you have to factor out an x. So you're left with x times x cubed, because x times x cubed is x to the fourth, plus x times 2. X times 2 is 2x. All right, so now we got to rewrite. We have to rewrite all of these as your answer. Now we normally, you see how this is a binomial, and this is a monomial factor? always put the monomial factor first. We're going to have x times 3x minus 1 times x cubed plus 2. All right, and so notice that this right here, that answer right here, looks like this answer. Now, just be aware. Remember, we said that we tend to put the monomial factor first, and that's what you want to do. But notice the order in which you multiply does not matter. So if you had written it as x times x cubed plus 2 times 3x minus 1, that's still okay, because multiplication, remember, multiplication is commutative. So the order in which you multiply does not matter. Okay, let's do one more example. So let's look at this one. So we're going to have number 2. We're going to do one more. So number 2, let's cover this. All right, number 2, you have 24 minus 8x plus 12x squared minus 4x cubed. All right, so 24 minus 8x plus 12x squared minus 4x cubed. All right, so it's always a good idea. Remember, it's always a good idea to factor out the GCF first, because notice you had this, and then you had all of these steps. So if you didn't factor out the GCF first, look at what you had to do here. So it's quite a maybe 1 or 2 more steps you had to deal with. All right. Whereas if you do the beginning, it's more straightforward. All right. So when I do this problem, I'm going to go ahead and find the GCF to begin with of all 4 terms. So the GCF of all 4 terms here is 4. So GCF equals 4. So I'm going to rewrite this polynomial. I'm going to rewrite this polynomial as 4 times 6 minus 2x plus 3x squared minus x cubed. So 4 times 6 is 24. 4 times 2x is 8. 4 times negative 2x is negative 8x. 4 times a positive 3x squared is 12x squared. 4 times a negative x cubed is a negative 4x cubed. Now remember, what we do is we want to take this little part here. Also remember that in your answer, make sure you don't forget about the GCF. That's a common mistake people make. They leave this off, and that should be part of the answer. Okay, so rewrite this over. And then we're going to group the first 2, group the last 2. In the first group, I can factor out a 2. And so you're left with 2 times 3 minus x. In the second group, the GCF here is x squared, so plus x squared. And I'm going to get, again, 3 minus x. So from these 2 groups, right here, these 2 groups, my GCF is 3 minus x, and I'm left with 2 plus x squared. All right, now again, that's not the answer, because to begin with, you also factor out a 4. So the answer is 4, I'm going to bring this down, 4 times this. So 3 minus x times 2 plus x squared. Okay, and so that is factoring by grouping, where you take out the GCF of all 4 terms to begin with. Again, so in this video, the GCF of all 4 terms was not 1, so it was something other than 1. In the previous problems, the GCF was 1. Okay, so you should be able to work problems dealing with this idea.